So we are going to demonstrate something known as double slit experiment, but we are going to do it with diffraction grating. So this is a simple demonstration from the chapter of waves of grade 12, grade 11, sorry. So we are going to see, so focus on the screen. You see this is a laser and you see the light is traveling in a straight line. Is it visible, sir?
Yes, sir.
Yes, alright. So now, move the camera, give it to me, towards me. So you see this grating, and now when I place it, you see the change. What happened to the light? The light ray got diffracted, and you can see the diffraction pattern. Somewhere there is light, at some places there are no light. So we got a center, sir. Can anybody, Sueva, can you go there and point, help me out with the central bright fringe? Yes, can you let me know which one is central? Central bright fringe, and then followed by, this is the first bright fringe, but what is the difference? This is dark, exactly. And on the right? Another dark, and then the first bright fringe. So you can see there are more than few fringes observed. Acha, can you tell me which one is the fringe width? This one is the fringe width. Alright, now stay there. I want all of you to concentrate on something, alright? I want you to see whether the green light, now let's see whether there is a green light or not. Second green light. So for the green light, do you see the same pattern or do you see the fringes are a bit further? A bit further. So blue or violet was a bit closer. Green is a bit further. Why? Wavelength of green is greater. So the separation of the fringes will be more. So you saw that, right? So green without the grating it's straight, but with the grating it's broken down into constructive and destructive interferences. So where they're constructively interfering at the center and then the bright spots. And at the places where you don't see any light, that's destructive interference. Alright. Now let's see here, sir. Come over closer. So now you have it. So we are going to see that this is a white light, right? And when you pass the white light through a grating, something weird happens. You see this? So this is diffraction of the white light. So we all know white light comprises of how many colors? Constitutes 7 colors. You can see the rainbow, right? The rainbow color. But what I want you to see, without the grating, all the light just sums up to be white. But then, when you place it on a grating, it gets diffracted. And you can see here, we are having a constructive interference followed by destructive interferences. And then again a constructive interference, first bright fringe on both sides. And if we move it a bit further, you can also see the glimpse of second bright fringe. Do you see that? Halka dekha jacche, second bright fringe? Yeah. Alright. So when you have this second bright fringe, I want you to see one more thing, one more difference. The first bright fringe is very close to each other, whereas the second bright fringe is spreaded. And on the center you see white light. Why? Exactly. In the center, the waves meet with a path difference of 0 lambda. So as all the 7 colors are reaching at the same point, so it appears white. But when you see in the first bright, all the colors are not reaching the same point at the same time. So red being the higher of the wavelengths, having the longer wavelength, appears on the furthest side, and violet, having the shortest wavelength, appears on the closer side of the spectrum. So red, longer wavelength, goes more, spreads more, and violet, shorter wavelength, closer. The second bright fringe, why the spreading is more? Because the light travels much further, and when light travels much further, it spreads out more. So this question is in your grade 11's MCQ paper. They're going to ask you white light separation pattern, fringe separation pattern. So I hope it made sense, right? Alright, thank you.